Morning, sir.
Good morning, Gurmeen. How are you doing?
Good yourself?
Good.
So, the experience from the past days about the learning in open nature, about polynomials, their behavior, their graphs, and the way things work, it was quite phenomenal,
Wow.
so to speak, right? Because you're not just in a classroom, but you're openly spaced. Especially with the quadratics, we saw how we could apply things like that with nature. So we just, so to speak, we just learn better, say if you will, right?
Good to know all that.
Yeah.
And I always believed in it. So now it works out, right?
Right, it works out fine. So now, with that also comes a great amount of curiosity.
Sure.
By that I mean the amount of questions for polynomials just proliferate,
Oh
so
my
to speak.
God.
So the first question I'd say probably would be, there are a couple factors that may affect turning points.
Yeah.
Because turning points is also a cool concept. You know what I mean?
Yes.
So what I'm guessing is that, what I'm getting at is, I want to know how things like leading coefficient, x-intercepts, so real zeros, and degree affect the number of turning points for a polynomial.
Very good question.
Yeah.
I will say that you've actually missed the major part which affects the number of turning points, and that is zeros.
Yeah.
Zeros alone can tell you about the number of turning points in case of a polynomial graph.
Yeah.
I'll show you how.
Okay.
Right, so basically leading coefficient tells you the end behavior when it is combined with the degree.
Yes, that's true.
Alone, leading coefficient will tell you what happens when x approaches infinity.
Yeah.
So in that case, the
Right.
sign is same as the sign of the leading
Leading
coefficient.
coefficient.
As far as the degree is concerned, that tells you whether both are facing the same sides or the opposite
Opposite ends.
ends. But when it comes to turning points, zero plays a critical role.
Okay.
So if I know the number of zeros and their multiplicity,
Yeah.
I can exactly tell you how many turning points will there be.
Okay.
So let us say that we have 5 zeros.
Okay.
So when you have 5 zeros, then they correspond to 5 real x-intercepts,
X-intercepts,
right?
yes.
That's what. Now, out of these 5, let us say 2 of them have even degree.
Okay.
2 of them have even degree.
So to the power of
E,
2.
2 or 4 or 6,
Yeah.
right? Yeah, that's what exactly. So when there are zeros, I should say x-intercepts,
Yeah.
the graph has to turn, get to the next turn, get to the next, like this.
Yeah.
So if there are 5 x-intercepts, there has to be 4 turning points, one
Yeah.
less.
That makes sense.
One less, right? Because they have to turn and then get back.
Right.
Now, if the zero is of even multiplicity,
Yeah.
it turns extra at that point, because when it is even, it doesn't change the sign,
Yeah.
right? So it bounces back like a quadratic function parabola.
Right.
So that adds to the number of turning points.
Okay.
So all even zeros will add to the number of turning points. So how many turning points do you get if I tell you all about zeros of a polynomial?
So first of all, you said there
Let's
was
say we have 5 x-intercepts, and these corresponds to zeros, as you know, out of which 2 have even multiplicity.
so to the power of
Let's say 2 or
Let's say
4.
2 or 4.
So in that case, 5 will correspond to 5 minus 1,
Which is
4
4.
turning points, and these
Plus
2 give you
additional
2. So
Okay.
4 plus 2 is 6.
6.
You get the point?
That's so cool.
So that is how you get 6 number of turning points.
Okay.
So that's how we do it. So only zeros is sufficient to know the number of turning points. That's it.
Yeah.
So that's how we do it.
Okay.
Yeah.
So what I'm thinking is, why don't we have like a class outside?
Oh, sure.
Questions
So
like
let's
these.
bring a board here
Okay.
and work it out, and I'll show you this example on the board
That's a
itself.
good plan.
That should sound better,
Better,
right?
yes.
So let's go and get a board, okay?
Okay, all right.
Yes, let's go.
Hello, sir.
Hi. Do you like the classroom, Gurmeen?
I do. It's
So-
such an open environment.
Yeah.
So let's see if we can make something out of it.
Sure.
So we were just previously speaking of turning points.
Yeah.
So with that, we were talking about how zeros and their degree play a role in
Right.
determining how many turning points a polynomial can possibly have.
Sure.
So why not we try some question like that?
Sure.
Okay.
So let me take the example which I took, right?
Yeah.
So we are talking about turning points, right?
Yeah.
Okay. So we are talking about turning points. What is critical to know about turning points? Tell me.
So it would be for zeros.
Just zeros, right?
Real zeros.
Just real zeros, right?
Yes.
So we are looking for Real zeros.
Yeah.
What do you mean by real zeros?
Real zeros are where the x-intercepts.
Oh, yeah,
Right.
x-intercepts plus we have the information about multiplicity
Or
or
order.
right? That is kind of it.
Yes, that's important.
Order, right? So this is what you should be knowing, right?
Yes.
So let's take 5 real zeros
Okay.
to begin with. Right?
Yeah.
So we'll take 5 real zeros and then figure out how many turning points are possible, right?
Yes.
So what I could do actually is I could sketch it right away also on this, right?
Yeah.
Let's say this is it. And when we say that we have 5 real zeros,
Yeah.
and we're talking about a polynomial,
Right.
we are saying it could be 1 0, 2 0, 3 0, 4 0, and the fifth is
Fifth
0.
zero.
Do you see that?
I see that.
So we have 5 real zeros.
Right.
How many turning points? Tell me.
So if you have 5,
So 1 turning point, 2 turning point,
3
3
turning,
turning point, 4 turning points. So what you notice here is that for every 0, the graph has to turn. Polynomials, as you know, are
Right.
continuous graphs,
That makes
right?
sense.
No breaks, smooth curves. So they have to turn. So between 2 zeros, there is 1 turning point, 1 less than the number of zeros. Correct?
Oh.
So basically, if this is a degree 5, because there are 5 zeros, right? What you notice is that we have 4 turning points. Do you get
Right.
an idea?
I do get an idea.
But could the turning points be increased for a 5-degree function?
They can,
How?
if the order was even for some zeros.
Oh my God, you have good knowledge about it. So you really understood what we were talking about.
Yeah.
So let's take an example for some zeros which have even degree, right?
Right.
So let me sketch how will they look like, right? So let's sketch again, and this time I'm still going to maintain degree of 5,
Okay.
but have some zeros
Yeah.
which will have different multiplicity.
Yeah.
Does it sound okay?
It sounds okay.
Okay. So basically what I'm saying here is that this is 1 0 linear, this is 2, right?
Yeah.
So we have 2 zeros.
Yeah.
So we have taken degree of 2, right? And then here we go and turn, let's say. So if I'm turning,
Yeah.
it's an even 0, right? So this is even.
Even.
Because it turns. This is an extra turn.
Turn.
Do you see that? So we got 1, 2, 3, 4, right?
Yeah.
And then degree 5 going back. So right? So what we have here is how many turning points?
1,
1,
2, 3,
three,
4 turning points.
4 turning points. So let's write down. How many zeros do we have now? 1, 2, 3, 4. We have 4 zeros. So if there are 4 zeros, how many even zeros?
Even you have about
1. 1 even 0, right?
Yeah.
So the number of turning points should be 4. Take away 1 because that is the number of turns.
Yeah.
But this gives you 1 extra.
That's
plus
so
1.
That's so cool.
So we get how many turning points?
4.
4. Do you see that?
Oh.
So this formula really works.
Okay.
Now, here is a question for you to solve.
Yes.
Right?
Yes.
I'm not going to sketch a graph, but I'll give you polynomial equation in factored form.
Okay.
Right? And then you have to figure out how many zeros it can have. And then sketch me the graph and show me.
Okay.
Does it sound okay?
It sounds okay.
Okay, fine. So let's start with something like x, and then we'll have x minus 1. Let's say this is my even 0, and then we have x plus 2, right? So, and then let's say this is also even 0. I'm making 2 even zeros this time.
Okay.
Right? Let me call this as x cubed.
Okay.
So you'll understand that, you know, the odd zeros don't really contribute much to your this, right?
Yeah.
Okay, and let's take another root here. Let's say x plus 4. Is it okay?
Yes.
Now tell me, how many turning points will this polynomial have?
So first we have to jot down the number of zeros we have.
Okay.
And that's 4.
So we have, let's say zeros are 4.
Yes.
Right. Okay.
Take away 1.
Okay. So we are turning points. So turning points will be 4 take away 1.
And you'd have to add 2.
Why?
Because there's 2 real zeros.
Oh my God. So you add 2
2.
for 2 real even zeros, right? So we are talking about even zeros, right?
Yes.
So even zeros are 2.
Yeah.
These 2 are even.
Even zeros.
So you get 4 minus 1 is 3,
3.
and 3 plus 2 is
5 turning points.
So you expect 5 turning points. Let's see.
Can we sketch this and
Oh,
see?
you should sketch it, yes, and verify. Is that okay?
Yes.
Okay, so let's sketch it. So, okay, let's keep the equation here. We have very limited space to work with.
Right.
Now, I would like you to sketch this down, right? So, here's the graph.
Okay.
Can you sketch? Use this, okay. You sketch. So, these are your zeros. First mark your zeros and then we'll see how to sketch. Yeah.
Okay, so this is your x.
Yeah.
And then you have plus 1.
Yeah.
Then you have negative 2.
Perfect.
Then you have negative 4.
Yeah. Let's say, keep it here. Keep it here. Okay.
Negative 4.
Okay.
Now, in order to sketch,
Yeah.
before we even do it,
Yeah.
we would have to draw the behavior,
Perfect.
Right.
That is right.
right? We
Yeah.
have to draw the behavior.
Yeah, yeah.
So let's start off with this one.
Yeah,
that's-
because you are now sketching the graph of a polynomial.
Right. And now the leading coefficient is positive.
Perfect.
And the
So right
degree.
side up, right?
Right side up.
Yeah.
And if you look at the degree,
Yeah.
2, 4, 5, 6, 7, 8. So it's even.
8,
So
yeah,
both
even.
sides up.
Both sides up.
Right.
Yeah, perfect.
Yes. So
Like
we would draw an even first.
Now you have to see how many. Yeah, even. Or
the
say
power of
linear.
1.
Okay. So you're coming from this side.
Yeah.
And you'll be ending up there.
Right.
So your graph is going from quadrant 2 to 1.
1,
Correct?
yes.
Okay. How does these zeros behave? Now let's mark those first.
Okay. So
So at 4, it is linear.
linear.
Okay.
If you look at this degree is 2,
Yeah,
so
yeah.
it's gonna turn,
Yeah, yeah. Okay. Very good.
right?
Just
It's gonna
take
turn.
that up,
And then you look at this zero, it's cubic.
Yeah.
So it doesn't know where to go.
Yeah.
So it's going to be like this.
Perfect. Perfect. Yeah.
Right.
Yeah.
We can even draw this, I believe, a bit
Slightly
farther.
away. Yeah. Yeah.
It might be easier for us,
Yeah. It should.
considering it's a limited space.
Yeah, yeah.
But we
Sure.
can work with that.
That's
So
true.
this was 1.
Yeah.
Now, if you notice, this
This
is
one, yeah.
also even degree.
Yeah, it
to the
is.
power of 2.
Yes.
So it's in the same way. So it's gonna
Turn and go back. So end behavior is perfect, right?
Yes. So now we
Okay.
can connect it, right?
Yeah. Yeah. Yeah.
So because they're continuous, they're
Yeah.
gonna go on. There's no
Yeah.
break in between.
Yeah. Yeah.
There,
Perfect.
there,
Perfect.
there you
X.
go. Now let's look at the number of turning points.
Count.
Because previously we said they were 5, right?
Yes.
So we have 1,
1,
2,
2,
3,
3.
4.
This is not a turning point.
This is not a turning
right?
point. No.
4.
5.
Perfect. Wow. You got it.
It works out even.
Perfect. So we'll do some more exercises on this when
Yeah.
we go back to the class.
Okay.
So I'll post a few multiple
Few more
choice questions for you.
Okay.
So practice those and then we'll have test on polynomials.
Okay.
Does it sound okay?
That sounds perfect.
right?
Yes.
Okay, great. Good job done.
Thank you.
Thanks. And
Thank
I
you.
hope the whole concept is absolutely clear.
Clear. And it's clear in my mind.
Yeah.
And now I can work well with a factored form.
Yeah. Can you summarize this for our students? Right.
So basically, we were looking at if you don't even need to know the leading coefficient and degree if you're determining turning points, especially when it's factored form.
Okay.
All you have to look at your real zeros and their degree. When you have your equation laid out like this, you have to look at, to find how many turning points you have to look at, first of all, how many real zeros you have. Take away 1 and add how many even zeros you have.
Perfect.
Right?
Yes.
So that would determine your turning points.
Yeah.
And you can graph that. And when you go to graph, we talked about that in our previous video. So if you don't have a clue, visit that first because you need to know how to graph a polynomial from a factored form.
Yes.
And then you would look at, mark your x-intercepts. Before you draw the graph, mark their behavior based on their multiplicity. And you can connect. And after, check if your turning points match your final answer.
Yes. Great job.
Thank you, sir.
Thanks.
Take care.